In question 8, we are given two similar shapes. Um, so basically what I've done is to separate them into two so that you can be able to notice the corresponding sides. So basically from the information that you're given, AD is 5 and BC is 6, PQ is 9 and QR is 12. The first question is to work out DC. So let DC, So let DC be X. Let me just plug in a variable, so X. So we know that if two shapes are similar, then the ratios of the corresponding sides should be equal. So what that means is that X over 12 should be equal to, and we can pick two corresponding. So basically we are comparing those two, and we can pick two corresponding sides like those ones there. So X over 12 should be equal to 6 over 9, which implies that X should be equal to 12 multiplied by 6 over 9, and that will be equal to 8 centimeters. And that's the value of DC. And then to find AR, we can let that be Y. So Y over 5 should be equal to, again, 9 over 6, because those are the corresponding sides, which implies that Y will be equal to 5 multiplied by 9 divided by 6, which is 7.5 centimeters. And then part C, and I think I'll work out part C here so that we can be able to see the shapes as we work through it. So part C, we need to find, we're given that the area of this quadrilateral ABC is 32. So here area is equal to 32. And you're required to find the area of the shaded part, which is this portion here. Now notice that the shaded part is basically the differences between the areas of the two quadrilaterals. So the ratio of the sides So the plan is to work out the ratio of the sides. Then from the ratio of the sides, we find the ratio of the areas. From the ratio of areas, we find the area of the larger quadrilateral. After finding the area of the larger quadrilateral, find the shaded area. So the ratio of the sides will be equal to 9 over 6, and that will be equal to 1.5. And then from there, the ratio of the areas, so ratio of the areas will be 1.5 squared, which is 2.25. So area of the larger quadrilateral, so area of APQR, this larger one will be 32 multiplied by 2.25, and that will be equal to 72. So from there we can be able to find the shaded area, which will be 72 minus 32, and that will be 40 centimeters squared. That's basically how you work out that question. All right, so let's move to number 9. So in number 9, we have triangle PQR, which is an enlargement of triangle ABC. And the first question is work out CR. All right, so what I want to consider here is these two triangles. Let's consider this triangle here and this triangle here. Okay, so if we consider those two triangles, let's see how this will look like. So we have the smaller triangle here, the larger triangle there, something like that, not done to scale. All right, so here OC OCA, and then we have ORP. Now the corresponding um, lengths for both of this will be, let's just say this is 3 and that is 3.5. These are just sketches. They don't represent exactly the triangles as they are here. So you have 15 here, and then we have OR, which is missing like that. Okay, so the first question is, how do we find CR? So CR, it's part of OR. So let's just find OR first. So OR, which is X over 3.5, should be equal to 15 over 3. Because these two triangles are similar, then the ratios of the corresponding lengths should be equal. So this implies that X will be equal to 3.5 multiplied by 15 over 3, and that should be equal to 17.5 centimeters. So the length from here to here is 17.5, which means that CR will be 17.5 minus 3.5, and that will be equal to 14. And now part B, find AC. So to find AC, let's just label it Y. If you use those two triangles, so Y, and by the way, this is 19. So Y over 19, so Y over 19 should be equal to 3 over 15. So Y over 19 should be equal to 3 over 15, which implies that Y will be equal to 3 multiplied by 19 over 15. And that will be equal to 3.8 centimeters. And then the area of ABC is 2. So the area of this guy here, by the way, from our calculations, we have the length of AC, which is 3.8. So this is 3.8. But we're also given the area of this guy. So area of this guy is 2. So they want us to find the area of PQR, which is this one here, this triangle here. So look at this corresponding lengths. Maybe we can use this corresponding lengths to find the ratio of the areas of these two triangles, and then we can use those to find the area of the larger triangle. So I'll start from there. So the ratio of the sides, we have 19 over 3.8, and that will give us 5. So ratio of the areas will be equal to 5 squared, which is 25. So the area of the larger triangle, which is PQR, will be 25 times the area of the smaller triangle, which is 2, and that will be 50 centimeters squared.